This is a vectors question, 2006, question 2c, and the question is, if O is the circumcenter of this triangle, and if H down here is A plus B plus C, show that AH is perpendicular to BC. And to get started in this question, you have to know obviously what a circumcenter is. So just to remind you, circumcenter is, if you can imagine putting the point of a compass on 0 and putting the pencil on the point A, well, you could draw a circle that would go through the 3 points of the triangle. That's what a circumcenter is. It's the center of the circle that goes through the 3 points of the triangle. And so translating that into maths language, what that means obviously is that 0A would be a radius, as would 0C, as would 0B. So circumcenter, what they're trying to tell us in a roundabout way is that 0A, that length, is the same as the length OB is the same as the length OC. That's our starting point. We're given that. We're given that that's a circumcenter 0. In other words, we're given that 0A equals 0B equals 0C, which is the radius. Now, the next thing is we're trying to show that the vector AH is perpendicular to the vector BC. So that even to just look at the diagram, AH would go from A to H, obviously. BC, the vector from B to C. So they would have to be perpendicular, and we don't need the diagram as such to do this bit. We just need to realize that if you're trying to show that two vectors are perpendicular, that means over and over again in exam questions, if you're trying to show that two vectors are perpendicular, it means to show that their dot product is 0. So notice that's two things that in the question that they're given to you in a roundabout way. They're giving you the circumcenter as a roundabout way of saying that OA equals OB equals OC, and then they're telling you to prove that AH is perpendicular to BC, which is a roundabout way of saying to prove that the dot product of AH dot BC is 0. So learn from that. The way they have phrased questions, often they ask you something but they really mean something else. So just get used to the kind of language that they're using here. So when they say perpendicular, they're really asking you to show that AH dot BC is 0. Now we use our well-known formula for AH, which is H minus A. So we can also put these vectors into H minus A. So AH is H minus A, and in the same way BC is C minus B. So notice how this formula comes into every vector question as well. And now we just multiply out the brackets. We get H times C or actually I just started something else we can do here. Just go back a bit. For H I can now sub in this because we're given this also. A plus B plus C. So I'm just subbing in for H because we're given that, we're allowed to use that. Minus A dot C minus B equals naught. And of course the A's cancel. Minus A. And now we've just simply got the vector C plus B by C minus B. I'm just writing this one backwards to make it look like the second bracket, to line things up. And just be a little bit careful here. I know if this was algebra, it would be just x plus y by x minus y, but in vectors we just need to do things with a dot. You know, so just be a little bit careful. It's C by C, so C dot C, and minus C dot B. So again, just multiplying out brackets. Plus B dot C minus B dot B. And the two middle terms cancel. And now we have C dot C. Now C dot C, by definition of dot product, is, so we'll actually just leave it as that first. C dot C minus B dot B. Which is equal to, dot product is the modulus of C. By definition, it's the modulus of C by the modulus of C again, by the cos of the angle in between, which is 0. The angle between C and itself is of course 0. Minus, same thing for B, the modulus of B by the modulus of B by the cos of the angle between B and B in itself, which is of course 0. I'm using my dot product formula here, which is just to remind you, A dot B. Definition of dot product, the right definition of dot product is A dot B is equal to A modulus of A by the modulus of B by the cos of the angle in between, which is theta. That's what I'm using. And now the cos of theta is just 1, so we have the modulus of C squared, back up to here again, the modulus of C squared minus the modulus of B squared. And this brings us back up to here, the modulus of C, in other words the C which is really OC, because that's the vector notation. If the vector C is really the vector OC and the modulus of it is the length of OC, but clearly that's the same as the modulus of B, OB. So these two are equal, so clearly if you subtract them you get 0. And that's what we're trying to prove. So that's, we've just proved that AH is perpendicular to BC.